Imagine something that can simultaneously have two completely different faces, not as a trick or a play of the mind, but in a real, living, and tangible way. As if a coin were neither heads nor tails, but both at the same time, heads and tails in a single moment. Something that seems absolutely impossible in our everyday world, but in a strange and invisible realm called the quantum world, this phenomena is not only possible, it is the fundamental rule that governs everything. This astonishing phenomena is called quantum superposition. Here, the boundaries between the possible and the impossible become so blurred that even existence itself takes on a new meaning and definition. A hidden secret at the heart of reality that challenges our minds and raises a profound question. Is what we know as reality merely one of countless possibilities? Quantum particles like electrons or photons behave in ways that are vastly different and much stranger than the microscopic world we can see and touch. They do not exist in just a single, well-defined state, rather they can simultaneously experience multiple different states. Imagine an electron being in two separate locations in a space at once, or a photon possessing both vertical and horizontal polarization simultaneously, much like a musician playing multiple notes at the same time. But the truly extraordinary part is that these simultaneous states remain real as long as we do not observe them, that is, as long as we do not measure them. Like a living painting that is incomplete without a viewer, the quantum world holds all its possibilities alive until it is observed. This leads to a fundamental question. Is the particle truly present in several places at once? Or is it simply that we are unable to pinpoint its exact location? The answer lies in the concept of the wave function, a mathematical expression that contains all possible states of a particle. When we measure the system, this wave function suddenly collapses, revealing only one final outcome. Put more simply, until we perform a measurement, the particle is like a lake wave spreading in all directions. But the moment we look at it, that wave becomes a single specific point. In the 1930s, Erwin Schrödinger, one of the greatest names in physics, proposed a thought experiment that still puzzles physicists and philosophers alike. He said, imagine placing a cat inside a sealed box, along with a radioactive particle, a detector, and a vial of poison. If the particle decays at the particular moment, the detector triggers the release of the poison, the cat dies. But if the particle doesn't decay, the cat remains alive. Here's where the quantum aspect comes in. According to the laws of quantum mechanics, until it is observed, the radioactive particle exists in both decayed and undecayed states simultaneously. And because the cat's fate depends on the state of that particle, the cat also enters a strange state of superposition, both dead and alive at the same time. Until we open the box, we cannot say whether the cat is truly dead or alive, or more accurately, until we observe it, the cat genuinely exists in both states. This is not merely a scientific joke or an entertaining paradox. It is an attempt to illustrate that in the quantum world, reality may not even exist unless it is observed. And this is where a much bigger question arises. Do we create reality simply by looking at it? Does the universe have anything to show without an observer? Or are we the ones who, by our presence, by our act of observation, pull reality out of the sea of infinite possibilities? The Schrödinger's cat experiment blurs the boundary between science and philosophy, a sealed box, yet full of mysteries that could redefine the nature of the universe itself. If in the quantum world everything can exist in multiple states at once, then why do we never see a child that both exists and doesn't? Or a cat that is simultaneously alive and dead? Why does our world appear so definite and consistent, while the world of particles is overflowing with probabilities? The answer lies in a phenomenon called decoherence. Quantum particles, when isolated, can exist in countless superposed states. But here's the problem. Our universe is not isolated. No particle exists in absolute vacuum. Light, heat, air vibrations, collisions with other particles, all of these make up the environment. And when a quantum system interacts with its environment, something crucial happens. Superposition collapses. The wave function that once held all probabilities is forced due to interaction with the environment to choose just one of those states. This happens incredibly fast, faster than we could ever perceive. In fact, our universe seems to be constructed in such a way that these remarkable quantum superpositions remain only on extremely tiny scales. The moment something becomes larger or interacts with the external world, decoherence kicks in and ends the quantum game. That's exactly why you never see a table existing in two corners of the room at once, because billions of surrounding particles force it to be in one definite place. Decoherence is that thin, invisible line that keeps our world classical, while just beneath its surface, a universe of probabilities is still boiling and surging. Imagine that every time you make a decision, another version of you in another universe chooses differently. It might sound unbelievable, but this is exactly one of the official interpretations of quantum mechanics: the many worlds interpretation. In this strange view, whenever a particle is in a state of superposition, say existing here and there at once, a separate, independent universe forms for each of those possibilities. And when we measure it, we simply remain in one of those universes. It is not that the other possibilities disappear. We just no longer see them because we are no longer that version of us. In this sense, every choice, every observation, every tiny event might branch off a new strand of reality where a different path was taken. This means that billions upon billions of parallel versions of yourself could exist right now. One who never watched this video, one who made it, one who became a scientist, one who never believed in quantum physics at all. And all of them are real. In the many worlds view, wave function collapse never actually happens. Nothing is selected. Everything happens, but in separate, non-communicating worlds. Now the big question is, which version of ourselves are we? And is there any way to peek into the others? The answer remains unknown. But this is one of the few places in science where the line between reality and imagination nearly disappears. You might think superposition is just a strange concept for physics. But the truth is, the future of our technology is built precisely on these weirdnesses. At the heart of quantum computing, qubits don't just represent 0 or 1. They can be both 0 and 1 at the same time. And this opens up a world of parallel computations. A world where problems that are almost impossible for classical computers can be solved in moments. But there's a major obstacle. Maintaining this superposed state is like holding a drop of dew in the middle of a storm. The slightest contact with the outside world collapses everything. That's why building real quantum computers is more like trapping a fleeting spirit inside a bottle. A challenge that even the most advanced laboratories on Earth have yet to fully overcome. Quantum superposition is not just a physical law, it's a window into a world where reality is not something fixed or absolute, but rather like a silent melody woven from thousands of possibilities from which only a single note emerges when it is heard. When you look, when you choose, when you measure, the universe reveals just one of its infinite faces to you. Not all of them, only the one that harmonizes with your gaze. And this is just the beginning. In the next chapter, we will step into one of the most mysterious phenomena in physics: quantum entanglement, where two particles, even from across galaxies, still seem to feel each other's presence. Until our next video, goodbye.